Hey, good morning, students. It's Miss Murphy, and today's lesson is going to teach you one strategy to solve a quadratic equation, and it's called square tactics in Desmos, using the property of squaring in order to solve. So let's take a look at this activity. Yeah, we have an expression x squared plus 10x. Is represented here with algebra tiles in the picture. How many unit tiles do you need to add to make it a perfect square? So you can see the perfect square would include this white space here, and we're trying to figure out how the value of this white square, the area of this white square. Okay, so I know that the length is 5 because it's the same distance as up here. And I know that the width is also 5 because it's the same distance as this. So this is a 5 by 5 square, which would be 25. There we go. Okay, so what do you notice about each equation's structure? Well, I'm noticing that every equation has an exponent of 2. And every equation has an equal sign. I'm also noticing that the number that the equation is equal to, these are all perfect squares. The square root of 25 is 5. The square root of 16 is 4. Which equation can be solved by taking the square root? Equation A can be solved by finding the square root instantly because of the parentheses. So the entire expression is squared. So we can start by undoing that operation with the square root. These others, we would need to move these terms um, in order to do a square root or somehow factor to combine terms. Okay, we're going to solve this equation. Use up to 2 rows to write your solution. Use paper if it helps with your thinking. Okay, Well, there should be 2 answers because we have a power of 2. So I'm going to start by trying to factor. Let's see if we can, let's see. I know this equals 9. If I factored, I could factor this like this. 4 times 4 is 16. 4 plus 4 is 8. Okay, once I put it in factored form, I have those parentheses like I was mentioning on that last page. So now I can do a square root. So I'm going to square root this side, and I'm also going to square root the other side of the equation. When I do that, I'm left with x minus 4. There's no power of 2 because it cancels with the square root. The square root and the power of 2 cancel each other out. And then I have to evaluate the square root of 9, which could be 3, but it could also be negative 3. So I'm going to write plus and minus 3 because 3 times 3 is 9. Also, negative 3 times negative 3 is 9. My last step is to add 4 on both sides. Now, if I'm adding 4 to a positive 3, I get 7. But if I'm adding 4 to a negative 3, I get 1. So there's my 2 solutions. And I'm plugging the solutions back in. Plug 7 in for x and see if it equals 9, and it does. That's how they're checking and showing their work there. Take the solution of 1, plug it in for x. Does it equal 9? Yep, it works there too. Okay, we have 2 methodologies here. Um, okay, so yeah, K did the exact same method that we did on the last page. So factored and then took the square root of both sides. Devin, okay, so Devin decided to move the 9 over and set the equation equal to 0 and then factored to find the roots. Same answers, different methodologies. Okay, the word algebra comes from the title of a book. The book was written in 830 CE. This is where we believe that algebra began. And the focus of the book was to solve equations just like the equations we're solving now. What are some different ways you could solve this equation? Kind of hard to read that. It's very small. Um, so basically, different ways we could solve this equation is um, the two methods that were described on the last page are two different methodologies that would work for this problem as well. We could try to make it equal to 0 and then factor. Um, there's also a method called completing the square, which we kind of seen on the first page, where you find the missing value here, the missing part of the square, um, and add it into the equation. So yeah, I guess I would say we could factor, complete the square, and always graphing is an option too. Graph and see where it touches on the x-axis. That's the easiest and fastest way to solve an equation, any equation really. Okay, so okay, so the author chose to add in this number 25, just like we seen on the first page. So the missing part of the square was a 5 by 5. He added it on both sides of the equation. How does this help? Well, when you add in that perfect square number, this side of the equation is now factorable, whereas previously it was not factorable. And then we would add these two numbers together, take the square root. So when things are factorable, let's write this out. Excuse me. Once it's factorable and everything's in those parenthesis groups, then you can easily take the square root of this side. I'm not going to do the whole thing, and the square root of these two numbers combined to get your answer. We're just talking about the methodology, not finding the exact answers. Okay, so how would that work here? Let's see. We're going to find the missing number to add. Um, so we looked at an example just, recently where we had a tile diagram and we knew it was a 5 by 5. So we added 25 on both sides. Now in this example, I'm going to show you something different. Completing the square really is just the process of doing two steps to find that missing number. I like to call it the magic number because once we get that magic number, we can completely factor um, the quadratic. So it's kind of, makes things more manageable. But the magic number is found by dividing by 2 and raising to the power of 2. So you find that b value, that number that is with x, divide it by 2 and raise it to the power of 2. Well, 14 divided by 2 is 7, and 7 squared is 49. Um, this is a scientific calculator. I'm going to show you all the steps. So let me just do a split screen. This is a really good way to organize your work. And I don't always like writing with that pencil tool. My handwriting is a little hard to read. So um, let me just move this over here. Okay. So we have x squared plus 14x. Now, if we divide by 2 and get 7, 7 to the power of 2 is 49. So that is our magic number. And we're going to add 49 on this side. And then on the other side, we also have to add 49 because we know that we have to keep equations balanced. Now, as mentioned, you can find your solutions here by looking at the graph. You can see that they're really awkward decimal values. So we might have some square roots involved in our solutions, but we see the answers. We just want to understand, where do the answers come from? So once we complete the square, we get that magic number. Now we can factor. All right, 7 times 7 is 49, 7 plus 7 is 14, so that factors nicely. On the other side, we need to figure out, what is 49 plus 31? Well, that's like 50 plus 30. That's looking like 80. I know I haven't made any mistakes because my red and my blue graph are identical, so nothing has been messed up. Now we're going to take the square root of both sides, so x plus 7. Remember, taking the square root with a power of 2 cancels out. Those are opposite operations. And then I need the square root of the other side. There's a square root button down here, and we need the square root of 80. Okay, so what's going on with our graph? It's only showing green on one side, and that's because when you do the square root, you need to find the positive and the negative. So I'm going to show on this row the negative square root of 80. So now we have both sides separately. Okay, the last step would be to subtract the 7 on both sides of the equation. If I subtract it over here, it's going to go away, cancel out. Positive 7 and negative 7 cancel out. So minusing 7 on both sides gives our two answers. Now we knew what those answers were. We can see that it matches with the graph. Same over here. This is the decimal form of the answer, but this is the radical form of the answer. Sometimes it's nice to have things in radical form. So let's write our answer here. If you type SQRT, you should get that square root symbol. And we are out of the box when we minus 7, not underneath the box. So there's our first answer, and then we want our negative SQRT square root of 80, come out of the box, and minus 7. So we have our two answers. Let's see how that works. Everything's checking out nicely. And here's how you show your work. Okay, you can always do a screenshot of the rows in Desmos and upload it into a Google Doc. Maybe you want to take good notes, or maybe you want to collaborate with your teacher or a student. Feel free to take screenshots of your work and share it with, in your collaboration with whomever you're working with. Okay, so solve this equation. All right, now if I were to divide 6 by 2, I would get 3. 3 squared is 9. That is not the number I have here. So this is not going to factor nicely to use the square root methodology. But what I could do, let's just get this written out. So here's our quadratic. We have two answers here. Again, they're unusual decimals, so the answer will probably be in radical form. I'm going to break this down very slowly, okay? It's okay to minus 4 on both sides. It's okay to do anything on both sides as long as you're keeping things balanced. You're doing them on both sides of the equation. Now, when I do that, let me just here, you can Control C to copy and Control V. When I do that, the positive and negative 4s, that cancels, that's 0. So I'm just going to delete that part. Over here, I'm getting negative 7. All right, so I'm simplifying my equation. Now I have something that I can complete the square with. All right, let's add in the magic number on both sides. Dividing by 2 6 divided by 2 is 3. Raising that to the power of 2 gives me 9. So I need to add 9 on both sides. Now I can factor x plus 3 squared. 3 times 3 is 9. 3 plus 3 is 6. So that's working out nicely. And on the other side, I have negative 7 plus 9, which is 2. Again, use your graph wisely, and you can see the green, the blue, the red, and the black are all the same graph. So that lets you know you have not made any mistakes. Taking the square root of both sides gives me the square root of 2, and we're missing one side because we also need the negative square root of 2. So I'm going to type in my answer. I have the square root of 2. I do need to move the 3 that's with the x on the other side, so I had minus 3 on both sides. And then the same answer with a negative square root of 2. Remember to come outside of the box. You're going to minus 3 on both sides. All right, let's give that a try. The system's going to show us that indeed those solutions will work out, and they check out nicely. Okay, Roberto made a mistake. What did he do wrong? Let's see here. Okay, so 12 divided by 2 is 6. 6 squared is 36. So he's adding 36 on both sides. But he didn't move this number over. So first you need to get rid of the value that is there. So he completed the square nicely with adding 36 on both sides, but forgot to move the 6 over before that. So this 6 should have been subtracted from 14, and then he should have added 36 on both sides. Okay, there's more practice if you need it, but that's going to just conclude our basic lesson for learning how to use square roots to solve quadratics. Thanks for watching.